In today's video, we are going to look at the argument of a complex number z, and is given by arg of z. By definition, the argument is the angle theta between positive real axis and the line joining the origin and z. Now, this is our Argand diagram. We have the real axis and the imaginary axis. Now, remember our z, we said that by definition is x plus I y, and it is just a set of points of x and what and y. So we are going to plot these 2 points on the Argand diagram. So this is our x and that is our y. So that is our z, which is x and y. Now we said that the argument is the angle between the line joining the origin, that is our origin, and z, and the positive real axis. So that is our argument theta. Now from trigonometry, we know that tan of theta, so we are talking about this theta, we are having our right angled triangle. So tan of theta is equal to, it is opposite out of the adjacent, and therefore the argument is going to be equal to arctan of y out of x, so which is the same as the tan inverse of y out of x. Now note the principal argument of a complex number should lie between negative pi to pi, i.e. our theta should lie between negative pi and pi. Let us do some examples and we illustrate the conditions. Example 1, we have our z is equal to 3 plus 3i. We need to sketch our Argand diagram, and we are having a positive 3 and a positive 3. This is our imaginary axis and this is our real axis. This is the origin. Now we can join these points. So that is our z and 3. Is that okay? Now this is our origin and this is our z. This is our real axis. So we join, we shall have our argument, which is a theta. And we said that our argument theta is tan inverse of 3 out of 3, imaginary over real, and theta is the same as tan inverse of 1. So what is the tan inverse of 1? Place your calculators. The argument theta is equal to 45 degrees. but remember the argument is required in terms of theta. Therefore theta is going to be 45 pi out of 180. So theta is equal to pi out of 4. Now we should note that this complex number of ours, it is in what? First quadrant. First quadrant is where our complex number lies. We have another example. We have z is equal to negative 2 minus I root 3. Is that okay? So we need to sketch the Argand diagram and we locate the argument. So this is our real axis and this is our imaginary axis. Now on the real axis we have a negative 2. On the imaginary axis we have, this one is 2i. On the imaginary axis we have negative 2 root what? 3. So upon sketching we shall have something of that sort, and we need this angle. We need that angle. So remember we say that our argument theta is equal to arctan of the imaginary axis, which is 2 root 3 out of a 2. Students, we take positive values of like the imaginary and the real, because for the negatives they just tell us that we are dealing with this quadrant. For example, we know that this third quadrant, all the values of x and y are what? Are negative. So here when we are finding the argument we consider positives. So our argument theta is equal to tan inverse of root 3. So what is tan inverse of root 3? It is a 60. Is that okay? So it is 60 degrees. And remember this 60 is from here up to here. And we need the angle from here up to here. Therefore, what shall we do? We are going to get theta, which is required, is equal to 360 minus DC angle from 0 up to here, and that angle is 240. Therefore we shall get theta 1 is equal to negative 1 what? 120. The reason why we call it a negative is because we are going to move from here coming this side, not this angle. Is that okay? This is the angle theta and this is the angle theta 1. We are interested in theta 1, not theta. So we need it in terms of pi. So theta 1 is equal to, divide by 180. So it is 2 pi. It is negative 2 pi out of 3. Another example. Students,